Objective 1, circles, part 1. We'll have 2 videos on this section. The first problem we're going to look at is find the domain and range of f of x equals square root of 16 minus x squared. You may guess this is a circle because the section's on circles, but looking at the function at face value, it's not quite obvious. But we can do a little algebra to convince ourselves that this is a circle. First of all, we have y equals square root 16 minus x squared. And if we square both sides, we get y squared equals 16 minus x squared. Move the x squared to the other side, and we have a circle of radius 4. This quite simply is a circle centered at the origin, radius 4, that's negative 4. But where it came from, this is f of x equals plus, which means we exclusively have positive y values. So it's actually the upper half of the circle, so we can erase that. And it is a semicircle. Now, as far as the domain and the range, domain is the set of all x values. X goes from negative 4 to 4. So the domain of f is from negative 4 to 4. And the range of f, range is by definition y values. Y starts at 0 and goes up to 4. Okay, fairly simple. If you understand something about the function, that's part of the key to analytic geometry, looking at a function and understanding what it is based on various parameters. Of course, that makes a domain and range fairly easy. We could have set up an inequality, could have used domain rule number 1. It would have given us a quadratic inequality. You're welcome to try that on your own. 16 minus x squared greater than or equal to 0, factor 4 plus x, 4 minus x, do a sign chart, etc., etc. Gives you the same result, but I'll leave that to you. Second example, f of x equals negative square root 1 minus x squared. This negative means it is a lower semicircle. And so we can probably skip the algebra in this case. We'll draw a rough graph. There's x, there's y. And you can understand what would happen if you unpack this by doing the algebra. That's where the radius is. Square root of 1 is 1. It's a semicircle. 1 minus 1, negative 1. It's a lower semicircle. And so the range of f is, in this case, 0 down to negative 1. Well, we'll do negative 1 up to 0. That way, our interval notation goes from lesser to greater. We always wanted to read from left to right. And the domain of f in this case is negative 1 to 1. Okay? Well, let's look at something a little more complicated. And we can analyze some fairly complex functions if we understand what they are. Now, let's suppose we have f of x equals negative 2 minus square root 9 minus x minus 3 squared. We want to find the domain and range, also the center in radius, and graph. Okay, and that's quite a bit, but it actually is not that difficult of a problem. We're going to let y equals negative 2 minus square root 9 minus x minus 3 squared. And move the 2 over here. We get y plus 2 equals negative square root 9 minus x minus 3 squared. Then we want to square both sides. We want to get rid of the radicals, put the circle in standard form. and we get y plus 2 squared is negative square root 9 minus x minus 3 squared. Square the whole thing. And let's come up here. We have y plus 2 squared equals. The square gets rid of the negative and the radical, but it doesn't alter what's inside. And so we have 9 minus x minus 3 squared. And then we're going to move this x minus 3 squared to the other side. X minus 3 squared plus y plus 2 squared equals 9. And we can tell the center is equal to 3, negative 2. And the radius is equal to 3. Okay. You may recall the standard form for a circle is x minus 8 squared plus y minus k squared equals r squared. And that's what our reference point for circles. Well, very easy to draw this. We can also go back. This negative in front of the radical tells us this is a lower semicircle. That's pretty important. When we square both sides and get rid of the negative, we end up adding solutions to this equation. We add many, many, many ordered paired solutions. In fact, we start off with the lower semicircle as a set of solutions. We ended up adding the upper semicircle. So you have to go back to the original function to figure out precisely what it is we have. And so let's draw a graph. There's x, there's y. We want the center at 3, negative 2. That's fourth quadrant. 1, 2, 3, 1, 2. There's the center right there. Let's add a few more points. And we can label our axes with a few numbers. 2, 4, in the negative realm. Now it's a lower semicircle, a radius of 3, so guess what? We can go to the right by 3, we can go to the left by 3, and we can go down by 3. And you can just connect the dots. There is the graph. This should come down a little bit lower, actually. My perspective is a little bit off here. Okay, we are at negative 5. So now as far as the domain is concerned, we have the graph to go by, easy peasy. Not that easy to analyze this function, by the way. You could set up a quadratic inequality to find the domain, and then the range, well, you could fudge that a little bit using some analysis. But in any event, the domain in this case is simply from 0 to 6. And the range, the lowest point is negative 5, and the highest point is negative 2. And so we go from negative 5 to negative 2. Okay, all that just understanding the nature of this function. So, okay, that concludes part 1 of Objective 1. We'll be back shortly with part 2, where we talk about completing the square. So we'll provide a good comprehensive review of that.